So here it's given that the sum of the first 4 terms of an arithmetic progression is 56, while the sum of the last 4 terms is 112. It's also given that the first term is 11. Using all these facts, we need to find out the total number of terms present in the arithmetic progression. So let's begin. First, we will consider, suppose let there be n terms in a given arithmetic progression, having the first term 11 and a common difference. This common difference is not specified, so we will consider the common difference to be represented by the letter D in lower case. Right. Using this information, now what we can do, we can say that the sum of the first 4 terms, the sum of first 4 terms, so this will be equals to, so there are 4 terms, so we have 4 over 2 multiplied to the first term, which is A, added to the 4th term or the last term. So last term here is simply the 4th term, A4. Right. And it's given here that this value is equals to 56. So let's try to solve this. So we're 4 over 2, that's 2, multiplied to A plus A4. So A4 is simply A plus 3D. So here we have used the fact that the nth term of an arithmetic progression can be represented as A plus n minus 1 times D. Fine. So with this is equals to 56. And dividing both sides by 2, and A plus A will become 2A plus 3D. So this is equals to 56 divided by 2. That will be, so we have 28. Now it's given here that the first term here, A represents the first term. So let me write it here. This is our first term, and this is given here that this value is equals to 11. So we can replace A with 11. So we have 2 times 11, that's going to be 22. So 22 plus 3D, that's equals to 28. So 3D, that will be equals to 28 minus 22, which is 6. And solving for D, we get the value D is equals to 2. So let's label this as number 1. We'll come back to it. Now next, it's given here that the sum of the last 4 terms is 102. So let's write it down. So we are given that sum of the last 4 terms. So the last 4 terms, that's equals to 112. Now, sum of the last 4 terms, that simply means we have 4 terms, so that will be 4 over 2 whole multiplied to the first term and the last term. So that means if we consider the last term to be an, then we have to go 3 terms previous to it. So let me write it down here. So let's say this is our last term represented by an, then the term which is previous to an, preceding an, that's going to be an minus 1, then followed by an minus 2, and the term previous to an minus 2 will be an minus 3. So that means here we will consider an as the last term and an minus 3 as the first term. So here we have an minus 3 plus an. So this is given as equals to 112. So let's solve this. So we have 2 multiplied to an minus 3. So if we expand it, this is going to be the first term plus n minus 3, that's n minus 1 times d, plus an, when we expand it, this is going to be a plus n minus 1 times d, and this is equals to 112. So let's substitute the value of a and d. So our first term is given as 11. So we're going to divide both sides with 2. So this is going to make, so this we can add 2a. So we know that this is going to be 112 divided by 2 on the right hand side, so that will be 56. So let's keep it aside. And on the left hand side, we have a plus a, that's 2a, plus we have n minus 3 minus 1, so that's n minus 4 times d, plus n minus 1 times d. We're going to use the value d equals to 2 as obtained in equation number 1. So we have 2a plus, let's take d as the common factor, so we have n minus 4 plus n minus 1 multiplied to d, this is equals to 56. So we have 2a, a is 11, the first term, plus we have n plus n, that's going to be 2n, minus 4 minus 1, that's negative 5 times d, d value is equals to 2. So this is equals to 56. So if we take 2 as the common factor, so we have 11 plus 2n minus 5 equals to, so we have 56, so that's simply equals to 2 multiplied to 28. So we can factor out 2 from both sides. Now we have 2n plus 11 minus 5, so that's 6. which is 28. So 2n is equals to 28 minus 6, so that's 22. So n will be equals to 11. So that means we have a total of 11 number of terms in the given arithmetic progression.